Hello everyone, welcome back to Soundarya Study Zone. In previous video we have already discussed about DFA and we have completed the course of DFA, right? So in today's video we are going to discuss about non-deterministic finite automata, which is called as NFA. So before diving into the NFA, let us just recall the major ideas behind DFA, because the best way to learn about NFA is by comparing it with DFA. So let's begin. Okay, so what is DFA? DFA is deterministic, which means it is very deterministic, which means for every state, for every input symbol, there is exactly one unique transition. So let us take Q0 as a state. Okay, for every state, every input symbol. Let us take 0 as a input symbol. So for Q0 state, 0 is an input symbol. So there is exactly one unique transition, which means Q0 on 0, it can move to Q1 only, right? So Q0 on 0, it can't stay on Q0, which means there can't be choices. One case it can move to Q1, or it shouldn't move to Q1, it can move to Q1, like that, which means there is only one unique transition is there in DFA, which means we already know the path, only that path should be chosen. Okay, so let us take one real life example. This is just for your understanding. So imagine you are driving and you reached one junction. Okay, imagine you are driving and you reached the junction. So here in DFA you have, there is only one road to reach the destination. Okay, in DFA there is only one road to reach the destination, which means there is no choice. You can move only in one road to reach the destination, which means for a single state, for a single input symbol, there is only one direction. Okay, so this is DFA. So we have cleared the explanation about DFA, right? Which means in a junction, for a particular direction or for a particular destination you have to reach, there is only one road. So let us take this as Q0 state, and you can only take one direction to reach Q1 state, okay, which is a final destination state. This is one condition. Now let us take another one example, that is there is another one junction. Okay, so there is another one junction. So here the thing is there are multiple roads. Okay, here there are multiple roads. So this, let us take this one as Q0 state. So here you have multiple choices, which means you can take left, right or straight, okay, to reach the destination. So the thing is DFA is deterministic, you have only one choice, one path. But NFA, which is a non-deterministic finite automata, the path is not already deterministic, it is non-deterministic. What you have to do is, you can, one advantage of NFA is you can move in all these directions same time, which means simultaneously. Okay, which means I will move for all the states simultaneously. My destination is this one. Okay, so I have reached the destination, so this string will get accepted. So I will explain this by taking an example so that it will be clear. The thing is, DFA is deterministic, NFA is non-deterministic, there is multiple choice and you can move to all the choice simultaneously. Okay, so I have taken the examples to show what is the difference between DFA and NFA. Okay, so here, so just look at these two examples and try to take out what is the difference. Okay, I will explain it. Just look at these two examples and think what is the difference. Okay, so at first let us take the example as string ending with 0. Okay, string ending with 0, we have to accept this. Okay, so Q0 on 1, it will be there in Q0 state only, because we need string ending with 0, right? So it will be staying on Q0 state only, and Q0 on 0 it will be moving to Q1 state. I missed one thing, that is here we need 0 again, right? Why? Because Q0 on 0 it will be moving to Q1. Q1 on input symbol 1 it will be there in Q0 only, but Q1 on 0 it can be there in Q1 state only. Why? Because I can have 1 0 0 0 ending, I can have any number of zeros, right? So Q1 can be there in this state only in any number of time. So DFA is a deterministic finite automata. This automata need input symbol for every state, right? Which means Q0 should have the input symbol 0 and 1. Q1 should have the input symbol 0 and 1. So if it is like this 1 0 1, it should move back to Q0 state, right? This is DFA, which is very clear for you. Now in the case of NFA, same example ending with 0, but it is different from this. Why? Because here we have 0 1, correct? 0 1 and 0 here. Why? Look here I gave 0 here, but here I gave 0 0 here. So in NFA we can have multiple input symbol which has, or we can take for 0 we have multiple cases, right? Q0 on 0 it can be staying in Q0 only, and Q0 on 0 it can be moving to Q1. Okay, there are multiple cases possible in NFA. This is the biggest difference between DFA and NFA. It can take multiple transition. It has many choices in NFA, but in DFA we should have strict only one fixed path. That is the difference between NFA and DFA. And here I have not mentioned what to do if I get 0 or 1 in NFA. This is also right in the case of NFA. That is, there is no need to mention some input symbol which has no value. Okay, it should end with 0. That is done. I can mention it like this also. It can be go back to 1, go back to Q0 state on 1. I can mention this, or look here I didn't mention 0, right? No need to mention this. In DFA we have to mention all the input symbol and all the states, but in NFA no need to mention that. This is the difference between DFA and NFA. Okay. Now, what is the official definition of NFA? So the formal definition of NFA is defined using 5 tuples, same like DFA. So I will not explain it in deeper because you have already know the formal definition of DFA, right? So the formal definition of DFA is defined using 5 tuple, and they are Q, epsilon, delta, Q naught and F. So Q, you already know Q is a set of all states, and sigma is alphabets, which means set of symbols or characters, and Q naught is the start state, F is represented as final state, and delta is the transition function. So if you just take any example, Q0, Q1 on 0 and 0, 1 like this. So here what are all the states? States are Q0 and Q1, right? So what are all the alphabets? Alphabets are 0 and 1, which means input symbols. And which is start state? Start state is Q0, and final state, which is represented by double circle, is Q1. Now what is transition function, which is an important topic. Okay, so in DFA transition function is Q. On any input symbol it will be moving to next state, right? One state on any input symbol it will be moving to next state, but here there is only one next state, but here there is two next states, right? So transition function is different in case of NFA. All other cases are same. So here in NFA, let us see how will be the transition function. So to represent the transition function, let us take two states. Okay, two states, they are A and B. Okay, so and alphabets as 0 and 1. So how NFA will work is A on 0 it can move to A on 1 it can move to B, okay, or A on 0 it can move to B, and now I will take only for 0, okay, A on 0 it can move to A on 0 it can move to B, and A on 0 it can move to A, B, and A on 0 it can move to empty string, which means it can be like Q0 on 1 it will be moving to Q1, okay. No need to represent 0 here. This one is also correct to represent NFA, which means A on 0 it can be moving to empty string also, okay. All these cases are correct. Okay, now let us take it for 3 states. Okay, now let us take it for 3 states. Look here, for 2 states it is done. Now let us take it for 3 states. They are A, B and C. Okay. So now A on 0 it can be moving to A. A on 0 it can be moving to B. A on 0 it can be moving to C, and it can be moving to AB. It can be moving to BC, it can be moving to AC, or it can be moving to all three, A, B, C, or it can be empty also. So when there is 2 states, we have 4 possibilities, right? And when there is 3 states, we have 1, 2, 3, 4, 5, 6, 7, 8 possibilities, right? 8 possibilities. So look here, what is 2 square? 2 square is 4, right? What is 2 cube? 2 cube is 8, right? So we can represent transition function in general form, that is delta of q into epsilon gives 2 to the power q, 2 to the power q, right? Which means how many states? 2 to the power that states will be the transition function. So we can check the possibilities of transition from one state to another state. This is the main difference in transition function, okay. So in today's video we have learnt about the difference between DFA and NFA, and we have also seen the formal definition of NFA. I hope this video helped you. If this video helped you, please don't forget to like the video, subscribe to my channel and share it with your friends who are learning finite automata. Thank you.